Hi friends, I am Dr. G. Srinivasa Gupta, Professor from Department of Mechanical Engineering, VJEC JYOTHI Institute of Engineering Technology. Today we are going to discuss a concept on gyroscopic motion in four-wheelers. Coming to the fundamental concept of gyroscopic action, we need to understand the rotating axis of rotating bodies, that is spin axis and spin motion, and angular velocity correspond to that spin axis. Similarly, if I apply some that entire spin axis, if you want to give some angular motion about other axis or other perpendicular axis, then that is called precession. As you know that precession means entire spin axis is going to rotate about perpendicular axis. Then there will be a gyroscopic couple about third perpendicular axis. So this is spin axis of rotating bodies. Then we are going to try to rotate about z axis, this entire spin axis. Then there will be a gyroscopic whatever direction. Then it will going to rotate. Okay. So that is called precession, rotating about perpendicular axis. Then there will be a gyroscopic couple or gyroscopic action about third perpendicular axis, so that the body is going to rotate about third perpendicular axis. That is action. As a part of reaction, it is going to try to rotate. Reaction part is and coming into stable position. So as we know that spin axis velocity, we are using the omega s, precession axis angular velocity omega p, gyroscopic couple, that is torque due to precession. We can calculate using this relation. Gyroscopic couple is I omega s omega p. As you know that the real-time applications in mechanical engineering, that is automobile, generally automobiles having rotating engine parts about some axis and wheels also spinning, four wheels of the automobile. Then automobile while taking a turn, car, left or right side, then this is called precession. The rotating parts and apart from wheels, these are called spinning. Then automobile is taking a turn, that is about other perpendicular axis, it is going to be rotated, means that is precession. So because of this precessional torque, or you can say angular motion, because it leads to torque, input torque, let us say actional torque, then about third perpendicular axis, the entire automobile is going to rotate. That is called gyroscopic action. How we can in ships and marine engineering ships, and as well as in case of aircraft, we have seen the application of this gyroscopic effect of this gyroscopic couple. Now we are going to see in automobiles. In automobiles, the concept of calculating gyroscopic couple involves, because in case of automobile, no wheel, four-wheelers let us take, any of the wheels should not lift off from the ground. What does it mean? The reaction by the ground on the wheels must be positive always. How reaction arises? We can take so many regions of reaction of the ground on the wheels. Let us say weight of the automobile. Weight of the automobile. Let us say weight of the automobile W. Okay. Then because this weight leads to ground reaction on all four wheels. Let us assume this weight is distributed equally in all four wheels. Then each wheel, the weight or ground reaction on the wheels is total weight by 4. Each wheel if I take. Then second one is, we know that rotating engine parts are, if automobile is taking a turn, rotating engine parts along with the axis is given precession. So wheels are spinning, rotating engine parts both. Effect of wheels, that is if I am able to calculate couple due to rotating of spin axis of wheels, then that is let me represent CW. Then because of rotating of engine parts, that axis also going to be rotated because of precision given about perpendicular axis. That is, let us say CE, engine parts, gyroscopic action due to engine parts, axis of engine parts, rotating parts, that is given rotation, entire axis about other perpendicular axis. So total gyroscopic couple is CT, let us say. So because of gyroscopic action, because of wheels spinning, gyroscopic action because of engine parts also already rotating. That axis of those parts is going to rotate because of precision. Because of these rotation, external torque or motion applied, angular motion, there will be a gyroscopic couple about perpendicular third axis, that is, let us say y axis. Because we have given precision about z axis and spinning is about x axis, then the about third axis, y axis, this is the automobile going to rotate. So if you consider all the four wheels of the automobile, okay, four wheels, this is wheel 1, wheel 2, wheel 3, wheel 4. Let us say automobile is going to take a turn, left turn. Then wheels are spinning. Okay, if you observe from the wheels near to turning side, then let us say wheels are spinning clockwise direction. That is, okay, clockwise. Clockwise means, okay, this is clockwise direction. You have to observe from wheels near to, these are called front wheels, these are rear wheels. Which are wheels are near to view, these are called front wheels, and wheels are near away from the view, rear wheels. Okay, then this is, if you observe from view from this front wheels, then the vehicle is the spinning axis of the wheels is clockwise, let us say. Then a vehicle is moving left turn, let us say, if you observe from top. Then from top we are going to give precision such that it is anti-clockwise rotation. Okay, the vector notation we are going to discuss. Okay, because it is rotating, spin axis is rotating clockwise. If you from front wheels, these are front wheels, these are rear wheels, let us say RW, FW. Okay, then vectorial notation, if you want to draw spin axis clockwise, if you from front wheels, then it is moving away from observer, viewer. Okay, 0 to A, okay, 0 to A, omega S. Plus omega E. Okay, separately if you take spinning axis of wheels and spin omega W, you can say engines omega E. Okay, let us consider both the engine parts and wheels are spinning about parallel axis. Okay, similar direction axis. Then it is given left turn. Left turn means, okay, vehicle is given left turn means this axis of the wheels is going to turn, okay, delta theta in delta t time. Let us say after rotation, the position of the spinning axis is OB. Then change of this angular velocity is A to B. This is about, you can see about third axis. If you give clockwise rotation, then this vector is going to move away from A to B. It is very much understood. Means clockwise. About y-axis, it is going to rotate. This is x-axis. Perpendicular, okay, is z-axis. And, okay, I am going to, this is z-axis. This is y-axis. About y-axis, because of gyroscopic couple, about y-axis, vehicle is going to take clockwise rotation. Means rear wheels are having contacted in the ground, front wheels are trying to lift up from the ground. Okay, we need to see most important thing is reaction part of these regions, gyroscopic couple on the all the four wheels by the ground. Okay, we are coming to that point. Okay, this angular momentum, all this concept is other way approach. Anyhow, gyroscopic couple we can calculate I omega s omega p. Here omega s only spinning axis is given rotation. Also engine parts also given rotation. Then you have to add omega s plus omega e in the total gyroscopic couple. That is we are going to see soon. Okay, so conditions for gyroscopic action. When gyroscopic action exists, if the body has some mass and it is spinning, Okay, spinning masses are rotating about axis, that is spinning, and we are going to give change in the direction of spinning axis along with the rotating bodies. That is called precision. That also must be exist. Then there will be a gyroscopic effect. If any of these are missing, there is no gyroscopic effect. I think you are able to understand up to this. Then I am going to we are going to discuss how the ground reaction on the wheels and how many ways the ground reaction exists in the four-wheelers. One is, if the I already told, ground reaction due to mass of the vehicle, ground reaction 1, let us due to mass. So each wheel I am writing ground reaction W by 4. W is mass of the vehicle and all wheels are sharing equally, let us assume. Then second one is the gyroscopic couple engine parts and total. Total is engine parts plus these wheels, let us say CW. Then this total, how it is going to, these are the wheels, how it is going to, okay, these wheels. Suppose this is the total torque. What is the total torque about? Y-axis it is going to give, that is the torque. Then this torque, in fundamentals of mechanics of solids or engineering mechanics. So what are the reactions of on each wheel? Front wheels, if you take, I can draw this diagram. These are two wheels, okay, front. Okay, then this is the torque applied. Then reaction due to this couple CT, we can write on the pair of wheels is CT by 2W. W is this distance, wheel axis, that is the width of the axle. Okay, are you able to understand? Then you can apply that equilibrium equations. You can get total coupled by 2W will give reaction on both the each wheel. Okay, then CT by W will give reaction on two wheels, one side, or CT by 2W is reaction on each wheel. Similarly, if vehicle is going to, because engine parts are rotating with high speed, there will be a centrifugal action. If mass center of the vehicle is somewhere, let us say some h from the ground contact, then this centrifugal force always act away. Centrifugal force is away from the circle towards the outer toward the away from the center of the circle. So this is centrifugal couple. Centrifugal couple, how do we calculate? Okay, we can calculate M means mass of the vehicle, R is, what is R? R is this radius of rotation, MR omega square. Omega square means omega is, we are giving precision, that is omega P. So MR omega square is force. That force into H will give centrifugal couple. Capital M we are using for mass of the vehicle, that's why MR, capital R here. R means radius of curve rotation, MR omega P, because precision we are giving, that is MR omega square into H is the couple which leads to because of centrifugal action. So here also, if you consider the concept of equilibrium equation applying on this couple, reaction by the ground on each wheel due to centrifugal couple is Cc by 2W each wheel. Okay, then we have all the four reactions. Reaction due to weight of the vehicle 1 plus reaction due to total centrifugal couple. Okay, see directions, because rear wheels are going to press more on the ground, means reaction, if you take rear wheels, the reaction is positive. Otherwise, if you take front wheels, the reaction is negative, because it is lifting off from the ground due to total centrifugal couple. This also, okay, CC, centrifugal couple will presses rear wheels, and front wheels is may not be, okay, maybe lifting due to, depends on right turn or left turn, it is rotating. Here also reaction due to centrifugal couple. So if you rear wheels you take, you may have due to mass always ground reaction is positive, and due to centrifugal action it may be positive or negative, depends on the front wheels or rear wheels. If I take front wheels, I have to use a minus sign. Okay, then this is a reaction on the of the ground on the front wheels, front wheel, each wheel if I take, and minus reaction due to gyroscopic centrifugal force which causes couple. So this must be, total reaction must be at least equal to 0 or positive, more than 0. Otherwise the wheels are going to be, front wheels SP is going to be lift off from the ground. Using this condition, whatever unknowns we need to find, we can find. This is the concept. There are 4 causes to reaction by the ground on the wheels. One is weight of the vehicle. Second one is rotating engine parts creates gyroscopic action, that is couple. And wheels are spinning, they are also creating couple, because these two are on same axis or axis parallel, same direction. So we can add throttle gyroscopic couple. And third one is due to centrifugal action, there will be a centrifugal action that leads to couple. That couple also creates some ground reaction on the wheels. The way we can calculate, I already told this one. So we can take one simple example on this concept, and if at all these 4 types of regions involved reaction of the ground by the on the wheels, then we can apply this condition. Otherwise in the problem just simply ask you to evaluate the couple, gyroscopic couple or action or reaction, how vehicle is going to maintain stability and what direction it is going to tilt. In those situations we need to respond accordingly, the required response required for statement of the question. So this is we know that a 4-wheeler car taking a left turn, radius 60 meter curve radius, and speed is 72 kilometers per hour. So speed we can say vehicle is moving with velocity 72 kilometer per hour, means the curve which is taking 60 meter radius, the vehicle is rotating with the speed in the curve, means wheels speed as well as engine parts while taking the curve, that speed is same. Is it or not? Entire vehicle speed in the turn, that is precision given to this we can calculate. Because how we can calculate? V is given 72 kilometer per hour. We can convert this into meter per second. Then what is omega p, precision angular velocity, equal to obviously V by R. R I am writing here uppercase letter for curve radius. Okay, if wheel radius or engine parts equivalent radius, I am using lowercase letter r. Okay, so omega p we can find out like this. And similarly engine rotates 3000 rpm, means and mass of the engine parts are given, means I, mass moment of inertia of rotating parts, and engine rotates 3000 rpm means omega of E, that means spin axis angular velocity of engine parts is, we can find 2 pi n by 60, ne given 3000. Okay, are you able to understand? I think. Okay, then diameter of each wheel, again coming to wheels. Okay, wheels radius is diameter is 0.6 meters, means half of that radius, and each wheel has a mass moment of inertia. Again for wheels mass moment of inertia is given. The track width of the car is, that is we are using to find out reaction couple gyroscopic couple by 2 into track width, that is I have used small lowercase letter w. For angular velocity I am using omega, that is smaller w, it seems to be like that. Okay, are you able to understand? Okay, so this is the concept. You need to find, okay, you have to assume that engine rotates in clockwise direction when viewed from front. Front means front wheels. Okay, wheels rotate in same direction as forward motion. Okay, so gyroscope couple you have to find due to engine rotating parts. Obviously I omega p. For engine rotates parts I, whatever given IE omega p omega of E, whatever you are going to calculate here. Okay, IE is given here as 1.8 kg meter square. Okay, that is one thing. Second one, gyroscope couple due to 4 wheels. Wheels you need to take. So wheel spinning velocity, here in this case, how much wheel spinning velocity? Vehicle is moving 72 km per hour. That is vehicle velocity V, and wheel radius is 0.3 meters. So V by this 0.3, that is 72 into, okay, anyhow 5 by 18 is meter per second, whole by 0.3 will give omega of wheels. Okay, omega p same because all are given precision same. So I of this wheels 1.2 kg into omega wheels and into omega p will give, that is second one, gyroscope coupled due to 4 wheels. I think you are able to understand. Then it is also asked total gyroscopic effect, means sum of these two. But 4 wheels there are, don't forget. So 4 into, you need to write gyroscopic couple on each wheel due to each wheel spinning plus engine parts, IE. Okay, 4IW, 4CW. Okay, because CW you know that I wheels moment of inertia and omega wheel and omega p. Okay, I think you are able to understand. This 4 times of this will give, okay, total gyroscopic effect of wheels 4 CW. This is CW, right? Okay, CW, right? 4 CW plus CE will give total gyroscopic effect and its influence. Coming to influence, okay, now I will explain how the influence is, means we are viewing from front wheels. Okay, this is the vector omega of wheels as well as rotating parts vector, let us say omega. Then this is direction of 0 to A. Then the motion is given is vehicle is going to take a left turn. Left turn means this spinning axis is going to rotate in this direction. So that means this spinning axis taken a turn, let us say OB, delta theta, that is precision, delta theta by delta t, you know, omega p we calculated how. Then this is the change in angular velocity, or due to this angular change in angular velocity is angular acceleration, that is we can say omega into omega p. Omega means spinning axis angular velocity. So then if this means gyroscopic couple is, okay, if you rotate clockwise AB vector, how do you get? If you rotate clockwise about y axis, then vector going from A to B. So this is gyroscopic couple, means what happened? The vehicle okay, front wheels are lift off and rear wheels are down, this pressing the ground. Gyroscopic reaction is opposite, B dash to A dash, let us say. Then it is going to try to, vehicle is going to try to, because of reaction, it is going to move opposite direction tilting about y axis. So that stability will be maintained of the vehicle. If the vehicle is able to maintain, able to tilt itself, then it is going to offer resistance, that is reaction couple means resistance. If it is unable to offer resistance, what happen? Vehicle is going to skid down, fall down. Are you able to understand? This is the consequence of gyroscopic effect. Okay, with this gyroscopic effect on four-wheelers is, I think you are able to understand. Okay, in coming next lecture, we are going to discuss much more about this. Thank you. Thank you, one and all. I am concluding this lecture here. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.